Good morning, this is Andy Schweitzer. It's a video pertaining to our one of the two big atomic structure trends that are displayed on the periodic table, and that would be atomic radius. It will play roles in bonding and is one of the main ways which the AP exam uses to see that if you understand atomic structure. So a couple questions that we'll look to answer on this PowerPoint are: what happens to the radius when you add electrons? What happens when you add protons? What happens when you add protons and electrons? Can you explain the trends of the periodic table? So one thing that you should be pretty much aware of is that when the question is asked, you cannot use the periodic table as a reason. That's a big no-no. You have to use atomic structure content. You can't just say, well, X is bigger than Y because it's lower on the periodic table. Can you compare atomic radiuses of ions? Alright, so a couple things here. One, let's take a look at the periodic table. And some of it is more intuitive than others. But what happens as you go down the periodic table? Every time you go down, since the periodic table kind of matches the energy levels, meaning this is the first energy level, fourth, fifth. Okay. Every time we go down an energy level, we're literally adding on a significant amount of size. We add on 2 energy levels, then so 1, 2, 1, 3 energy levels. So the size gets extremely large as you go down. That usually for students is not that hard to understand and not that hard to explain. What's relative to the size of, let's say, chlorine, actually that'd be fluorine versus chlorine. Well, chlorine has an extra energy level, and that's why it's bigger. You could go one more down to bromine, again the same thing. Bromine's bigger than chlorine. Iodine is bigger than bromine, all because of additional energy levels. Now, the rest of this is going to look at, so let's say side to side. What happens between, let's say, I believe this might be iron and Fe, and let's say zinc, or let's say bromine versus krypton. Who's bigger, who's smaller? And we're looking at a fundamental situation here of the proton positive and how it attracts to negatives. And electrons are here and they're a certain distance away. All of this is going to revolve around, and this theme is going to hold true straight through bonding, and that is Coulomb's law. It is very difficult to explain any periodic trend or bonding without somehow discussing Coulomb's law, and that is sometimes also referred to as Coulombic attraction. Okay, and basically all we're saying here is that a positive charge will attract to a negative charge based on the magnitude of the positive and the magnitude of the negative divided by the distance squared equals the force of attraction between them. Now there is an equalizing constant, which we're never actually going to do any actual calculations with this, which sounds strange, that we'll use it as much as we do, but we will never utilize its actual calculation. So the K is there, but we don't always show it because it doesn't have it's just equalizing constant. So you could say, if you take the K out, then you could say it's proportional. You could say proportional. So a couple things. If I increase my charge, whether it's positive or it's negative, that's going to increase my force because it's part of the numerator. And then if I increase my distance, you should be aware that I will drop my force. Okay. Either way, we have a situation here where as we go down a row, what happens? All right. As I go across a row here, and you're going to start adding in a couple other fundamental ideas, I am going to essentially be taking a energy level, and I'm going to be adding both protons and electrons. Okay. Now, that is going to look at this question here. What happens when I add both protons and electrons? That's going to be basically traveling down a row of a periodic table. So what happens when I do that? Well, a couple of things here. One, understand that the protons are being added in a clump. That is going to essentially be taking your positive charge and allowing it to add. It is going to be getting bigger and bigger and bigger. So anytime I add protons to this particular center, okay, and that can be regardless of whatever I do. Well, I shouldn't say regardless of anything, but anytime you increase positive, you are going to be increasing Coulomb attraction, which means you're going to be drawing these outer electrons in. The electrons, however, are going to be spread out, so they would be all over the place. So their charge is essentially staying static. And you can look up the charge of an electron. It's going to be staying put. The protons, since they're piling up in the center, every time we add a proton, we add an electron. But the electron isn't causing a greater charge, because it's still just one electron being attracted to this thing. But the fact that we have more and more positives drags this thing in. So as we go down the row of a periodic table, it gets smaller on this side because of additional protons. All right. So as I go this way, I get smaller. This way, I get bigger and smaller. And how would you explain that? Additional protons. Additional protons means increased Coulombic attraction. Now, is it a ton relative to adding another electron orbital? Not really. It's just being slightly squeezed down as you go to the right. So it's getting bigger, slightly bigger as you go to the left, bigger as you go down. So francium is the biggest element on the periodic table. Has the most energy levels, and it's got the it's got the most energy levels, and in its energy level it's just one electron. So the proton has not had a chance to be squeezed down yet. But so first question is, what happens when you add protons and electrons? Okay, so what happens when you add protons, electrons? What happens when you add just protons? Well, I'll put it this way: any time you add protons, you get smaller. If you're just adding protons, every time you'll get smaller. Okay. We have our trend down, so now we're going to be able to look at some of the individual questions. I have already started here, because as we look towards ions and other things, you want to be able to deal with individual circumstances, and whether add protons or electrons, you just want to be able to work with it. So anytime you add protons, you are going to get smaller, period, because you're increasing Coulomb attractions. What happens if you add electrons? Just adding an electron, it is going to get bigger. And the reason why they're going to, I'll put this right here, what happens, so this is add protons, you will get smaller. Add simply electrons, and you will get bigger. Now, there's two things that can happen when you add electrons. You can add electrons to a single energy level. All right. In this case, electrons, the fact that they are negative, based on Coulomb's law, negatives repel, electrons will repel. So in this case, if I were just to add electrons, keeping the number of protons the same, to a single energy level, they don't necessarily like each other all that much. So it is going to swell slightly away and get slightly bigger. Okay, so if I were to just take a, again, this is getting off the periodic table, but if I were to add electrons going to the right, okay, that would going to get bigger. Adding more electrons gets bigger. I'm leaving the protons alone. An example of this might be an oxygen atom versus oxide atom. I would expect the number of protons are being kept the same. It is 8 protons. This guy has now 10 electrons. This one's going to be bigger. Okay, this one's going to be smaller, purely because we have additional electrons. Electrons repel. Now, anytime you add electrons, there's a possibility you could open a new electron shell. Anytime you open a new electron shell, you're going to get much bigger. And this might be even regardless of whether or not you are adding protons or not. If you add protons and electrons and you open up a new shell, you are going to be getting bigger. Okay, the trend shows us that. Now, the thing as well, I mean, I could frame this as far as adding electrons, but you should also be aware that if you were to remove an electron, okay, if you were to remove electrons, now again, if I moved them from a single level, I would get smaller, slightly. But if I removed electrons, eliminating an electron shell, it's going to get much smaller. And there are lots of examples of that. If we were to say, let's say, well, let's go with sodium atom, which has got 1 valence electron, to Na+1. Now, sodium has essentially removed an entire energy level, so this is much smaller. Okay. So either way, when metals and nonmetals gain and lose electrons to try to fill their outer shell, their sizes will be changing. The metals will be losing electrons, and generally they will be eliminating an outer electron shell, so they are going to be getting smaller. Whereas nonmetals, let's say fluorine going to fluoride, they're just going to be taking 1, 2, 3, 4, 5, 6, 7 electrons with one spot missing, and they're going to be filling it. So they're going to be getting larger, but not as much as these guys getting smaller. Just adding an electron, you just due to electron repulsion, gets slightly bigger. Okay. Now, again, I've highlighted what happens when you add protons, add electrons, and we've also talked about when you add protons and electrons, but I want to re-highlight that one more time. And when you add protons and electrons, okay, the proton attraction tends to be overwhelming the fact that we have an atom where we're adding both protons and electrons. Even though these electrons are slightly repelling each other, that's fine. It is not able to overwhelm the fact that this thing is got positive charge building inside here, and it will get smaller. Now again, I'm going to highlight 2 different ways. If as long as you are adding electrons in a single energy level, okay, you will get smaller. But if you open, okay, a new shell, you'll get smaller. Okay. The final thing I'll just touch on here quickly is the last little bit here is, can you compare ions? Okay, and you'll see some questions like this occasionally where they will say, okay, what would it happen if you were to have multiple ions, and who's bigger, who's smaller? There are some examples like this you might have, which would be, let's say, so let's call this comparing ions. Okay, you could have, let's say, oxide fluoride, and let's go with sulfide. No, let's go with nitride. Okay, and they want you to list these guys in order of atomic radius. Whenever I have a situation like that, I back up and I look at what's there. Okay, all of these guys, because they're attaining a full outer shell, you could also hypothetically include helium in this. Okay, helium. And you might say, okay, well, what's happening to our size here? Well, this guy has 7 protons and it has 10 electrons. This guy has 8 protons and 10 electrons. This guy has 9 protons and 10 electrons. This guy's got 10 protons and 10 electrons. All the electrons are in the same exact orbital. All right, so that's a moot point. Now we have to base this purely off of Coulomb's law and the fact that, okay, larger positive charge in the same distance. So we have larger positive charge essentially over the course of the same distance is going to cause it to pull in tighter. Same distance being the same energy level. We haven't drastically changed that. This is the smallest. This is the biggest. Okay. You could compare this on the metal side. Say, okay, what if we got Na plus? We have we got Mg2 plus. We have aluminum plus 3, and we can even back up again and say, okay, well, let's compare this to neon. Okay. Take a moment, look at how many protons are there, how many electrons are there. The neon, in this case, we got 10 protons and we have 10 electrons. We have sodium, which has 11 protons and 10 electrons. 12 protons and 10 electrons. 13 protons and 10 electrons. They all have the same number of electrons. Therefore, again, all we're working off here is number of protons. Coulomb's law. It will get smaller with number of protons. So this is the smallest and this is the largest, increasing in that direction. So in this case, you should be able to describe the periodic trend. You should be able to understand what happens when you add, subtract protons, electrons together or separate. Thank you.